is Tim Lynch. I'm with Schwab, Lubratt. We're the representative for Dan Bosch Drive in Minnesota, North Dakota, South Dakota area. Brian was asked to come and talk VFD, wastewater conservation, energy conservation. Unfortunately, he had a slight problem and couldn't make it, so he called me and asked me, and I rushed from Rockford to here in less than an hour. So hope there's no police force.
You didn't get caught.
Yeah, I didn't get caught, they didn't catch me. So, some of the places that we can conserve energy or use drives, water supply applications, water treatment, wastewater, irrigation booster stations. It's basically, it's a three-phase motor and you're holding it back somehow, valving it back, or have some type of restriction in the pipe. A VFD might be able to help you conserve energy by reducing the speed of the motor. There are applications where it doesn't save you energy on or money on the energy side, but it saves you money on the maintenance side. I'm not going to read everything for you. If you would like a copy of this presentation, I do have my card here with me, so if you want to send me an email and ask for it, I can definitely send you the complete PDFs so you can go through it and read it yourself. Just some of the key points, though, is you're tightening your dissolved oxygen control and improving your dewatering and reducing the water loss in the water system. One of the biggest maintenance things that we help improve, though, is eliminating the water hammer. That's probably one of the bigger items because pipe breakage costs a lot of money. This pie chart was put together by Van Moss, showing the energy used or the makeup of what total operating costs for a wastewater treatment plant is in general. Some of this, you might have some of these, some of them don't. You know, as all cities say, I know how to save money, which is reduce the staffing. Reducing staffing just makes more work for other people, and then they have to work overtime, so you're actually spending more money rather than saving. Where we can save you money with a drive is in your energy costs and in your maintenance material. Primary costs for wastewater treatment. 55% is done your aeration, your dissolved oxygen in your system. Another large one. The other biggest one is other. This is maintenance costs. Maintenance costs, pumps, pipes, seal, motors. So the two biggest ones are your aeration and your maintenance costs. Primary treatment is lift station. A normal lift station is an on-off motor, so it slugs the system. It's basically it starts when it's at a high level, stops at a low level. With the VFD on the pump, we can actually feed the system at a continuous rate, so that you're not slugging your systems. It helps with your chemicals. It helps with power consumption on the motors. If you reduce your speed of your pump motor by 10% or 15%, if it's a 20 horse motor, you're actually running at about a 5 to 7.5 horsepower motor amp draw. The drive drastically reduces the cost of the energy to run that motor. It also gives you a constant flow to the system so that you're not having these large slugs of waste and water coming into your system. As I stated earlier, eliminates water hammer, so pipe breakage, check valve sticking, frequent pump starts and stops. It's all there. The drive will actually cause the motor to run longer, but it also maintains a constant speed and you will wear less on your motor. You know, it's like driving your car with your foot all the way down on the floor and using the brake to set your speed. Benefits on your dryers. It helps on the rate. It helps the pick everything up, it helps, it slows it down enough that it actually picks up more weight, gets through your screens faster. Another brick conveyor, same thing. It's to help pick up as much solid as possible. You don't have to start and stop, it's a little easier in a conveyor belt. Energy consumption in the, excuse me, in the rest stage, we're really talking this 10%. That's where we're going to help with the clarifier. Anytime you can get the whole system on drive, it smooths the system out, it gives you a better control. With the drive on the system, you have infinite control with a valve. You might have quarter-inch clicks on your valve where you need to be halfway between, but you can't because there's no way of locking that valve in that position. With a variable frequency drive on any of your system here, you can control the flow in and out of that whole system. Benefits of the VFD and clarifier. One of the big things that and I just learned about this earlier this year was the prevention of the rat hole. So your sludge flows off on a nice constant flow. You don't get that slug of water down that hole. The continuous pump to the digester, that helps also. So you have a continuous flow through the digester. You're not rat holing and slugging your hoppers. It really does reduce the cost. We did a water treatment plant, and the Brian knows the story better than I do, that they were talking about having to add on to the water treatment plant because they just had such a large population growth and they had so much water coming in from their lift stations that they were slugging the system continuously. We put drives on their lift stations and gave it a more even flow, more constant flow into the water treatment plant. And they were able to hold out for about 2 years before they really had to do any upgrades to the water treatment plant. The drives do have a benefit, not just in energy savings, but in safety. If they can put it off for an extra 2 years, that saves the city that much more money. One of the other benefits to a drive is we can help control the chemicals going into the system. The drive is controlling the flow, but it also has an analog output that can tell a chemical pump, all right, I'm running at 45 hertz or 3/4 speed. I don't need a full dose of your chemicals. You can tell, give a variable speed to the chemical pumps to be able to tell it how much chemical it needs at the speed that it's running at. This is all done either through the SCADA system or drives. Our drives have enough intelligence to be able to help you out with that also. Secondary treatment stations. This is where we really get into with the aeration and stuff. Part of the issues of putting a drive on a blower, everybody's come to me and told me at the show even, is that they can't get the weights to lift it. They have to run it up so hard before the blower actually lifts the weights, and we actually get aeration going up the pond. A lot of drives have to have a secondary or 2-speed jumper put in order to make the drive operate that way. Our drive automatically, we can program it and tell it that we need a boost right away, and then we level up from there. We help the city of Pinkley with their DO by putting drives on their pond, and they run all 4 mixing aeration at the same time, and they've increased their production much better with the drives on the pond than turning motors on and off, on and off. They were losing motors, about 1 or 2 motors a year by just cycling them since we put the drives on, and then we'll lock them over. Here's fluctuation in your bio loads. With the DO, with the drive, with a DO sensor on it, we can control the oxygens in the system. We have a better control by feeding the drive that signal, letting it help you maintain your dissolved oxygen by reducing the speed of the aeration pumps. Just give you what you need instead of you turn the pump on, okay, we think you have enough, you want to check it, come back a couple days later, no, too high. You're constantly adjusting without a VFD, but with a VFD on it, we can maintain a much tighter DO. It's also easier on your compressors, like I said. If you're running your compressor wide open, it's like driving your car with your foot on the brake and trying to hold it at 55 miles an hour by choking it with a valve. With the drive on it, you have your accelerator pedal. Here again, you save energy. We process to improve the DO control. Less wear and tear on the aeration equipment. Any pumps that, or anything that runs at less than full speed, we save energy. If you need help figuring what the return on investment on a drive or putting a drive on any part of your system, we're more than happy to work with you and with your engineers to figure out what the return on investment on the drive would be. Currently, a lot of utilities are getting a rebate for putting drives on motors. They're also getting a rebate for changing the motor out, but just the drive to the motor, most of the rebates right now are giving enough money that it pays for the drive. Basically, you're paying for the installation. The biggest benefits, though, is that we save energy. We can save energy, we can save maintenance costs on any of the equipment that we put a drive on. This one pretty much tells you the same thing with your clarifiers. They can improve the efficiency of the paddles by controlling the speed. You have infinite control of the speed of the paddles and of the flocking you have. By controlling that speed, you have infinite control of that, so you know that when you are at optimum sludge producer, something like that, the drive will maintain that speed. I'm not going to read every one of these for us, but as I said, I will give this to you. If you give me an email account, I will send it to you or I'll mail it to you with that also. As I said before, it improves your efficiency here by maintaining your sludge blending. It also improves it by not rattling your system. This one, I've not had very much experience with this part of that system, so I really don't know the benefits to it, but they do have some that Dan Fox has talked many times. The minimization of hydraulic loading and the hydraulic disturbances of the clarifier is probably the largest benefit. In this one, we're talking full system. We've got a drive that we will just have a continuous flow through the system instead of our large slugs of water and then sludge. We're controlled by better carbon feeding and, of course, completely denitrification. I was sure we had to put a drive on my saltwater tank at home to help with the denitrification in that system. talking about the compressors. You eliminate water hammers from systems. We also eliminate large blasts of air through the backwash system here. If you're using like a sand filter or something, it doesn't disturb the layers of the filter. It's a lot easier on a system with a drive on it than doing large splashes of fluid. In this picture here, they're talking about the drive and how can control the chlorine dosage. Well, that's what I was saying, where the drive can give us the signal back to a chemical pump to tell it, all right, I'm running at half speed, I'm running at 3/4 speed. I don't need a full dose of chlorine. I only need X amount. Saves on your chemicals, saves on the pump, saves on the system. Here again, talking about the chemicals. We're talking about the continuous flow of feeding the digesters. With the VFD, we can get a continuous feed of fluid and sludge so that it actually operates at the optimum of that digester. We're not slugging the system, we're not giving it too much and not enough. Digester, once again, controlling the aeration. To control the pH and the oxygen in the system. One sensor, two drives. One on the blower, one on the mixer. Or you might not have the aerator on top. You might have the blower system. We can control the drive with an oxygen sensor, or the oxygen sensor can go back to your SCADA or whatever you're currently using to feed the drive a signal to maintain whatever you're looking for. On a centrifuge, the nice thing about a drive on a centrifuge is you're not getting that hard snap. It's a lot easier on the motor. You can get the centrifuge up to spinning. You save a lot more on the wear and tear of the motor and the bearings in the centrifuge than you do conserving energy. Usually you're running your centrifuge at full control. The drive can give us a high torque it needs to start, and then give us a nice ramp up. If your centrifuge is larger than what the system needs, I don't know if that's ever an issue. You can't control speed. You can limit the speed on the centrifuge. If you're having bearing issues where you know you're losing a bearing, you need to continuously still run this until the parts come in. With a drive, you can actually slow it down and not worry about killing that bearing. You can actually take a little easier on it. On and on. This one you're just going to have to shut her down. Basically, we're just controlling the speed of the unit, so it's like a drier cake. We're looking for less moisture that you're having to send to the landfill. The more water you can get out of the cake, the cheaper it is to use. At the beginning, we talked VFD groundwater, submersible pumps. You can run many cities with drives on their submersible pumps to give you constant pressure. We eliminate the water hammer. Energy savings is more in the treatment of the water than it is in getting the water to the top. On a submersible motor like this, you might only have a window of about 5 hertz that you can control that pump, but that 5 hertz gives you infinite control of your pressure and or flow. You take a surface water, same as a submersible pump, match your demand. We have constant flow or constant pressure. Eliminates the water hammer, eliminates frequent starts and stops. We maintain constant flow or pressure. Optimizing the mixing conditions in the tank and improving the coagulation. It helps you eliminate the solids not only that. Also gives you the optimum mix in your tank. I keep coming back to eliminates the chemical or helps with the chemical dosing. It reduces your chemical cost and it improves your water quality by giving you just what you need. You're not high in chlorine, low in chlorine, or whatever else, whether chemicals you're using to treat the water before you send it back to the system. Once again, this is the rat holing problem. The dry helps by maintaining the flow constancy. The sludge is a constant flow out. We don't get that little suck of water, the rat hole as they call it. It enhances the pump. It also maintains the pump at a constant speed so you get a better constant flow of material through the system. I was talking about the backwash on the filters. With VFD on there, you're not getting the large splash of water through there. We can maintain the flow through the filter. We can get a better flow through the filter so you're not mixing your levels and get a better backwash to use. What our treatment plants to do it with sand filters, we turn with the city of Edina with their sand filters. There's no disadvantage to putting a drive on a filter. Storage and distribution, as we said, we can control the flow. Our drives, I know some of you stopped by our drives have 4 different setups inside of them. So if you're working with a water tower system, you could have 4 seasons. You could have your spring, summer, winter, and fall levels with a flip of the switch or the digital input from your SCADA system. Eliminating water hammer to the water tower, a lot of them are open discharge from the water tower, so that really doesn't happen too often, but when the water tower gets to full level, I mean, a lot of our city has probably we go at night a lot of times. It's just easier. You can actually program the drive to only run at certain times of day. There's many advantages to putting the drive on your well. Benefits for using the biggest thing is eliminates water hammer. Stops your frequent starts and stops on your pumps. It reduces your costs on your maintenance costs on your control valves, on your display valves, on your pump. Maintains multiple pressure points, and it reduces water leakage because you don't have the high pressure like on a high service pump that you have valve back. Everything between that drive and between that pump and that valve is under higher pressure than what's on the back side of it. Same thing with the wastewater treatment plant, the chemical feeds for a water system is also the driver. So it'll help control chemical dosing so that you're not feeding too much fluoride or chlorine into the system. As it's been stating, we can control maintenance costs. Sometimes, like I said, depending on what the level of the pumping is, we might not save energy on the drive initial, but we do save many dollars in maintenance costs and constant flow of water through the system. We don't have any water hammer, saves on pipe breakage. There's a lot of the older cities have the the older pipes in the ground, and we've helped eliminate a lot of their pipe breakers by putting drives on their lift station pumps and on their city water pumps.